Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Printers contain a range of mechanical components that wear down over time, and when these parts fail, they often lead to severe printing problems. In both laser and inkjet printers, hardware faults can result in paper jams, low-quality output, or even complete printing failure. The components most commonly associated with mechanical issues include feed rollers, fuser assemblies, transfer belts, and various internal sensors. Each plays a vital role in the printing process, and understanding how they function and what happens when they break is a key part of supporting printer hardware. The A+ certification requires recognition of these faults and familiarity with their basic maintenance or replacement. Feed rollers and separation pads work together to pull paper into the printer accurately and reliably. The feed rollers grip the paper and advance it through the print path, while the separation pads provide resistance to prevent multiple sheets from entering at once. These components are among the most active in the printer, making them especially vulnerable to wear and contamination. As they degrade, users may begin to notice symptoms like paper jams or incorrect paper feeding. Understanding how these components interact helps pinpoint failures and determine whether cleaning or replacement is necessary. Symptoms of roller-related failure are usually visible and audible. When feed rollers wear down, they often lose the textured grip needed to handle paper correctly, leading to slanted or skewed sheets. Multiple sheets may feed at once, or the printer may fail to pick up paper at all. Users may also hear loud grinding or slipping noises during operation, especially during the paper feed phase. Upon inspection, technicians may observe that the roller surface appears shiny, cracked, or glossy, clear indicators of aging components that require replacement to restore proper feeding. Maintaining or replacing worn rollers is typically a straightforward process in many printer models. Before beginning any repair, the printer should be turned off and unplugged to ensure safety. In some designs, access panels must be removed to reach the rollers and separation pads. Cleaning the rollers with a lint-free cloth and isopropyl alcohol can remove surface dust and oil, restoring grip temporarily. If the rollers are visibly smooth, hardened, or cracked, they should be replaced entirely. Proper maintenance in this area helps prevent repeated jams and improves paper handling reliability. The fuser assembly is one of the most critical components in laser printers. Its job is to permanently bond toner to the paper using a combination of heat and pressure. The fuser contains heated rollers that press the toner particles into the paper fibers, making the printed image durable and smudge-resistant. For this process to work correctly, the fuser must maintain a specific operating temperature, often regulated by internal sensors and control logic. A malfunctioning fuser can lead to a range of visible print defects and may even prevent the printer from operating entirely. Signs of a failing fuser are usually evident on the printed output. If toner rubs off easily with a finger, or if the printed pages feel cooler than expected when exiting the printer, the fuser may not be reaching proper temperature. Wrinkled or crumpled paper can also indicate that the rollers inside the fuser are misaligned or warped. Many printers will display an error such as fuser error or maintenance kit required when the fuser is nearing the end of its usable life. Other symptoms like ghosting or uneven toner adhesion may also point to a worn or defective fuser assembly. Replacing a fuser depends on the printer's design and model. In many business-class printers, the fuser is modular and designed to be removed and replaced easily by the user or a technician. The printer should be powered off and allowed to cool completely before handling, as the fuser operates at high temperatures. After installation, the printer may prompt the user to reset the fuser counter in its maintenance or configuration menu. This step ensures accurate tracking of the new component's usage and may be required to clear any persistent maintenance alerts. The transfer belt is another key component, especially in color laser printers. It transfers toner from individual imaging units to the paper by layering each color in a precise pattern. This belt must be clean, properly aligned, and free of damage to ensure accurate color reproduction. If the transfer belt slips, wears unevenly, or becomes contaminated, color images may appear misaligned or contain artifacts. Because the belt handles multiple layers in rapid succession, even minor defects can lead to streaks, missing areas, or unwanted color overlays on the final print. Symptoms of a failing transfer belt can include color shifting, blurred images, or visible streaks across the page. If toner appears to be smeared between color sections, the belt may not be transferring the image cleanly. Some printers will detect transfer assembly issues automatically and display error codes or warning messages. Technicians may also find marks, residue, or scoring on the belt surface upon inspection. In most cases, replacement is the only reliable fix, although some printers allow limited cleaning of the belt if contamination is minor. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. The imaging drum, also known as the photoconductor unit, plays a central role in laser printing by carrying the electrostatic image from the laser assembly to the paper. This component is highly sensitive and must remain clean and properly charged to produce accurate prints. Common symptoms of drum-related issues include repeated marks in the same position down the page, a hazy background, or ghosting effects. These are typically caused by worn drum surfaces, charge leakage, or toner residue. In many printers, the drum is integrated into the toner cartridge, while others use it as a separate replaceable unit. Toner-related hardware faults may not be caused by the printer itself, but can still severely impact print quality and reliability. Low-quality or incompatible toner cartridges can clog toner paths, leave excess toner inside the printer, or fail to distribute toner evenly across the imaging drum. Some printers use sensors to monitor toner levels, and these sensors may give false readings if the cartridge lacks a proper chip or physical alignment. For best results, technicians should use toner from the original equipment manufacturer or from suppliers with tested, certified compatibility. Inkjet printers face unique hardware concerns centered around their ink delivery systems. Printhead clogs are a frequent issue, particularly in devices that are idle for long periods or exposed to airflow. Pump or cap station failures can prevent proper priming, and repeated cleaning cycles can exhaust ink cartridges quickly. If standard cleaning does not resolve streaks or missing lines, a deep clean may be required. In some cases, the printhead itself must be replaced. Proper handling and regular use are essential to prevent these hardware failures from appearing. Paper path sensors and actuators are critical for tracking paper movement through the printer. These small switches, or optical detectors, verify that the paper is loaded, aligned, and moving as expected. If a sensor becomes dirty, stuck, or damaged, the printer may incorrectly report a paper jam or refuse to feed paper. Cleaning these sensors with compressed air or gentle wipes can restore function. Technicians should also ensure that paper flags and actuator arms move freely and are not broken, as their malfunction can mimic mechanical problems in the feed system. Maintenance kits are packaged collections of high-wear components such as feed rollers, separation pads, and fuser units. These kits are designed to restore printer performance after a defined number of printed pages or a set period of time. When the printer detects wear based on internal counters, it may prompt the user to install a maintenance kit. Installing the full kit ensures that all critical parts are replaced together, reducing the risk of inconsistent performance. These kits are especially common in business-class printers with high monthly page volumes. A clear example of a printer service issue involves worn rollers. A user reports that pages often misfeed or jam near the input tray. Upon inspection, the technician finds that the roller surface is smooth and lacks the necessary grip texture. After replacing the rollers and cleaning the surrounding area, the printer feeds paper correctly without errors. The repair is documented in the service log, and a preventative maintenance kit is scheduled for installation at the next service interval. This type of structured response aligns with professional printer support practices. Firmware updates may occasionally resolve mechanical faults by recalibrating internal components or fixing known detection issues. For example, a firmware patch might correct how the printer senses fuser temperature or handle minor alignment problems with the transfer belt. Updates should always be downloaded directly from the vendor's support page and verified for compatibility. During the update process, stable power and connectivity are essential to prevent corruption. If interrupted, a firmware update can render the printer inoperable, so precautions must be taken to ensure a smooth installation. Environmental conditions have a direct impact on hardware longevity in printers. Dust can accumulate inside the printer, affecting sensors and contaminating rollers. High humidity may cause paper to swell or stick together, leading to feeding errors. Excessive heat can reduce the lifespan of toner cartridges, fuser components, and transfer belts. Printers should be kept in cool, clean, and well-ventilated areas to mitigate these risks. When not in use, covering the printer or powering it down helps protect against environmental exposure and extends its service life. Deciding whether to repair or replace a failed printer depends on several factors. For consumer-level models, especially those with integrated components, the cost of parts and labor may exceed the price of a new unit. In contrast, business-class printers are designed with modular parts that can be replaced easily, making repair more cost-effective. Technicians should evaluate the printer's age, usage history, and the availability of replacement components before proceeding. Budget considerations and total cost of ownership also play a role in determining the best course of action. In summary, printer hardware failures often involve rollers, fuser assemblies, transfer belts, imaging drums, and internal sensors. These components degrade over time due to mechanical stress and environmental exposure. Recognizing symptoms like repeated jams, poor toner adhesion, or color misalignment is critical to diagnosing the specific failing part. Regular maintenance, timely firmware updates, and proper environmental conditions help prevent many of these issues. For the A+ exam, understanding these failure points and knowing how to resolve or replace them is essential for printer support readiness. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.